Bing. I feel like I should be doing Mario Kart whenever I hear that. All right, so let's go 200%. The way that I always think of these is if there were just one number out in front of a set of parentheses, you all would know how to distribute it, right? If there's just a -6 in front, right, and there's these like parentheses right next to it, every one of you, I know for a fact, could easily distribute that -6 times every term, right? You've all seen that many, many, many times, okay? With polynomials, it's the same idea. You're still going to distribute a term to each term in that second set of parentheses. The only difference is you're not doing it with just that one term, but you're doing it with each of those terms in that front set of parentheses. So not only am I going to distribute that -6, but the 3x needs to be distributed and the 2x squared needs to be distributed. All right, so sometimes it helps if you like cover up each term or just take one term at a time and distribute it, by meaning like take this and multiply it by each term on the right side, okay? And once you do that, then go to the next term, distribute it, and then the third term and distribute it. And doing that shouldn't be that difficult. Whenever you're multiplying these terms, you multiply the coefficients together. Those are the numbers in front of the variables. So like this first one, we've got 2x squared times -4x squared. So first we multiply 2 times -4 and we get -8. But then we multiply the variables together, and that's x squared times another x squared. Whenever you multiply variables, you just add their exponents together. So I'm adding 2 plus 2 and we get 4. Because essentially x squared means that I'm multiplying 2 x's together. And if I have 2 x's and I'm multiplying it by 2 more x's, I'm total multiplying 4 x's altogether. So that's why we add those exponents. Now take this 2x squared again, and we're going to distribute it to the second term. And make sure you keep those signs in front, right? This isn't just an x, it's a -x. You can think of it as a -1x to the first power if you want. That kind of helps students sometimes writing those exponents above there, because a lot of times they do forget when it's just an x that it is going to change the exponent. So 2 times -1 gives us -2. And then x squared times x would actually become x to the third, because x squared says I've got 2 x's and I'm multiplying it by 1 more x. So that's going to add in a third x, making it x to the third power. Just like adding those exponents, 2 plus 1 is 3. And then take that 2x squared times 8. And here, there are no x's, so you just multiply those coefficients together. 2 times 8 is 16. And then the variable doesn't change. It's still just going to be an x squared. So that was distributing that first term on the left. Now let's go to the next term in that front set of parentheses. So I'm going to distribute 3x. So this 3x goes to that second set of parentheses, and we're starting off with a -4x squared. So 3 times a -4 is going to be a -12. And then x times x squared, remember this is like x to the first power. So you are going to add those exponents together and get x to the third here. Now I could just write this in one long line. I could write the -12x cubed here. But for me, it makes more sense to try to group it with the other exponents that I'm going to have to combine it with in my last step when I like combine like terms. So when I see that I've got an x cubed here, I'm going to bring it down below my other x cubes from that first distribution, from that first term. Because now, my last step, after I'm done multiplying, I can just add each like column straight up with grouping all those like terms together. It makes it much, much easier to do it this way. Then I take that 3x times -x. That gives me -3x squared. And look here how the x squareds are also lined up, right? Because I'm going to add those together once I'm done multiplying to combine those like terms. And then last, I'm going to take 3x times 8, which is just 24x. And it's not underneath anything else because there are no other just x's yet. Now I have one more term to distribute. I'm going to this -6. And I just distribute it times each of those three terms on the right. First, we have -6 times -4x squared. The negatives cancel out and give us positive 24x squared. So I'm going to write positive 24x squared. Again, notice where I'm writing that vertically. It's underneath the 16x squared and the -3x squared, because that's a 24x squared. Right? Once I'm done multiplying, I'm going to add all those x squareds together, so you only have one term with x squared in it. The -6 times -x is just positive 6x. And notice as I'm writing this, those x's are lined up as well. Last, I've got a -6 times 8, which is just a -48. And we're done with our multiplication, right? I've distributed every term in that first polynomial to every term in the second polynomial. And I've got them all lined up. So now I just think of this as one giant addition problem. I'm just going to add up each column that has those like terms together. Like term meaning it's the same variable with the same exponent. So starting from left to right, I've got the x to the fourth, and that's the only x to the fourth. So I'm just going to drop this -8x to the fourth. It's just going to drop straight down. There's nothing else to combine it with. Then I've got a -2x cubed minus 12x cubed for a total of -14x cubed. Then I've got all those x squareds. 16 plus 24 is 40, minus 3 is 37. This is positive 37x squared. Then 24x plus 6x is a total of 30x plus 30x. Then that last term, that minus 48, the constant, there's no other constants to add together. And that is our final polynomial. Anyone else get this? Okay, good. Good. That's awesome. How many terms are in this polynomial? Can you tell me? Just hold up with your hand. Good. All right, I'm seeing a lot of 5s. Exactly. So everything that's like separated by a plus or minus is a term, right? This is 1 term, 2 terms, 3 terms, 4 terms, 5 terms. One more question for you that I want you to just hold up your fingers. What is the degree of this polynomial? This was a concept I talked about in my lesson last week. What's the degree of that polynomial? All right. So the degree of a polynomial, very simple concept. It's simply the biggest exponent. And so my biggest exponent here is a 4. So this is a 4th degree polynomial. That's a term that you're going to hear a little bit throughout the year, and you'll definitely hear that a lot next year. So a 4th degree polynomial, just the biggest exponent. Any questions on this first one? Any steps that I did? I know online on the Delta Math assignment, they show a different method where you take like a box. Yeah, did anyone else use that method or make the box? Okay, a couple of you use that. That's awesome. Basically, the way that that method works is you take each term of one polynomial, like the 2x squared, the 3x, and the -6. So that's all from this first polynomial along the top. And then you do every term from the second polynomial along the side, like -4x squared, -x, and 8. And you just basically make like a table, you know, like a grid, here and here, there and there. And you just multiply each group together, like you fill in the box, right, in this row and column. So first I've got here, when I multiply the -4x squared and then 2x squared, that gives me a -8x to the 4th. You do this throughout the whole thing, and then just combine your like terms. You'll get the exact same answer. It's just a nice way to make sure that you're multiplying every term from one polynomial with every term from the second polynomial. So if you want to do that, that's awesome. That's great. You can totally do this method as well. I'm great with anything. All right, now for the new operation, division. Division with polynomials is a little crazy. So we are going to learn two different techniques today on how to divide these polynomials from each other. Now the nice thing is if we're dividing by just a monomial, so remember mono means one, so monomial means there's just one term. So see on the bottom there's just one term here. Hopefully you're going to get something like that because that's actually pretty simple. I'll make this a little bigger for everybody. All right, so go ahead and jot this division problem down. And essentially you just simplify each term in the numerator with that one term in the denominator. It's almost as if you split that up into three separate fractions, one fraction for every term in the numerator, all with the same denominator. It's kind of like the opposite of adding fractions. You know how you always have to get a common denominator to add fractions together to combine them? This is like the opposite. Like you already have a common denominator and you're separating it into separate fractions. So if you notice there's one term on the bottom, essentially you're going to kind of, oops, let me get a marker. Split up the numerator. And you're going to divide each term in the numerator by that same denominator and kind of just simplify each of those groupings separately. So I'm going to put a 3xy squared on the left. There's already one in the middle. And 3xy squared on the right. So it's like I took that one denominator and I'm going to divide each term by that single monomial. From here, all we do is simplify. And for this, you just kind of simplify each, I guess, not term, but within a term, all the like parts. So the coefficients get simplified, the x's get simplified, and the y's get simplified. So first, I see 15 divided by 3. Well, that just equals 5. Then I see x divided by x. What happens there? That just cancels out, right? X divided by x is just a 1. So gone, gone. And what about y squared divided by y squared? Same thing. They cancel out. So this first term simplifies to just a 5. Now we're going to go to that middle term. All right, so again, I look at just the coefficients, then I look at the x's, and then I look at the y's. So first looking at the coefficients, the numbers in front. I got 6 divided by 3. That equals a positive 2. Now we have x to the 4th divided by x. On the lesson last week, the Ed puzzle, I gave you a nice little trick to remember how to do this. Where are there more x's? On top or on the bottom? On top. And how many more are on top? There are 3 more, right? Because this is like 1x. There's 4 of them. So there are 3 more on top. So you put x to the 3rd up top, like in the numerator's position, right? Not in the denominator. And then same thing with the y's. Where are there more y's? On the top or on the bottom? On the top. And how many more? Just 1 more, right? You got 3 compared to 2. There's 1 more y up top. Finally, we go to that third and final term. we're going to simplify the coefficients, then the x's, and then the y's. Negative 9 divided by 3 is just negative 3. So I'm going to write minus 3. X to the 5th divided by x. Where are there more x's? Up top. How many more x's are up top? 4 of them. So we put x to the 4th up top. And where are there more y's? Up top, right? And how many more? There are 3 of them. So y to the 3rd. So dividing by a monomial, when there's just one term on the bottom, is pretty straightforward. You're just simplifying. Just simplify every term in the numerator by that one term in the denominator. So it's not really a skill or a technique. You're just simplifying. Any questions on this before we get to the really good stuff today? All right. Okay. Go ahead and jot this first example down. Looks a little weird, doesn't it? It's a trinomial, 6ab squared minus 3ab plus 2a squared b. But then it's being multiplied by something very strange. ab to the negative 1. That's weird for an exponent. What do we do? Inverse. Yeah, that's like the inverse, right, for matrices. And also last week on your lesson, the ed puzzle, I talked about exponent properties in special cases, like when you've got an exponent that's a 0, or when there's an exponent that's negative. Do you remember that? Like if I had something that was, I don't know, 2x to the negative 3. Remember seeing like a negative exponent with that lesson? We can't have a negative exponent, so what do? How do I get rid of that negative in front of the exponent? I saw someone gesturing like, flip it down. And yeah, essentially, you just move that base, which is the x, and its exponent, which is that negative 3. You move it down to the bottom, and then you make it a positive exponent. Now the 2 gets to stay up top, because technically that's 2 to the 1st power. It's got a positive exponent. So those negative exponents, they flip to the other side of the fraction. And so looking at this ab to the negative 1, this is really the same thing as saying 1 over ab to the positive 1. In essence, I'm just telling you to divide, right? Because if I put this whole thing over ab, so that's all that negative 1 is doing. This is like 1 over ab to the positive 1, which is just 1 over ab. So we're just dividing by ab. So everyone go ahead and divide each of those terms by ab. Awesome. Good. All right. Just remember, I'm just going to divide each of those terms in the numerator by AB. And you're really just simplifying. So this first term, the 6 is still there because there's no coefficient. A divided by A would cancel out. And then B squared divided by B is just B. It's a weird looking B. That second term, -3, because there's no coefficient in the denominator. Then you have A divided by A, which cancels out, and B divided by B, which cancels out. So we only have a -3 for that second term. Finally, we've got a 2, positive 2. A squared divided by A is just an A. B divided by B cancels out. And that's it. Anyone else get this? 6A minus 3, or 6B, excuse me, minus 3 plus 2A. Excellent. All right, so that is dividing by a monomial. Again, you're just simplifying. Pretty straightforward. Whew. All right, now it's time to learn some algebra 2. What about when there's more than one term in the denominator, right? Like if you're dividing by 2x minus 3. Well, you can't just simplify because there are multiple pieces there. So we get to use something called long division. Who remembers long division with numbers from like a million years ago? Yeah, you're like, see, okay, how many of this goes into that number? Then you multiply it, subtract, and then you repeat that process. Well, I hope you're familiar with that because that's what we're going to do with polynomials now. Same concept. Really is the same process as long division with integers. And so the important things are in red. All right, so if you want to just write in your notes, write down long division. That's this skill. This is one of 2 different division techniques I'm going to show you. This is the first one, long division. And the important thing are the 2 points in red at the bottom. So really important. This won't work unless both the dividend and divisor, those are just the 2 things you're dividing, they absolutely must be written in standard form. That's when you've got the biggest exponent first and it goes down by 1, right? So you'd have like the x to the third, then the x squared, then the x, and then the constant. So if you want to make a little note, biggest exponent first. Okay, so they both have to be in standard form. Parker? If there was like a polynomial like the one we did last time, like how would you write that one? So we're not going to divide those with multiple variables. So there is no real standard form whenever there's like an A and a B, because they could have different combinations of those. And so no need to worry about that. With a monomial, typically the degree would be the sum of all the exponents on the variables. So like AB squared would have a degree of 3 by adding them up, and you could compare that, but then you could have multiple terms with a degree of 3, so there's no real way to group them. So for us, for our division, we're only going to be doing these with a single variable. Nice question. All right, now when you're doing standard form, you always start with the largest exponent first, and you just count down, right? So if the biggest exponent is a 5, you're going to have x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x, and then the constant. Now, if you're missing one of those terms, this is what the second super important thing is. If you're missing a term, if you're missing one of those exponents, like if you have x to the 5th, then the next term you have is an x to the 3rd, and you're missing like an x to the 4th, you've got to put a 0 in for that x to the 4th. Otherwise, this will not work. It's going to mess up and give you lots of headaches. And I bet you on your test in 2 weeks that some of you are going to forget that 0 term. And I'm going to show you, and you're like, oh, I forgot about that. So don't forget that. It's really important for missing terms. And again, I'm going to show you several examples with these on how to work it. Are you ready? Okay. Dun, 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 dun. Polynomial long division. So we've got 2x squared plus x minus 16 all being divided by the polynomial x minus 3. So we can't do that grouping technique like we did with the monomial. You're not just simplifying each of those terms. Because technically this whole numerator is in parentheses, and this is in parentheses. So you can't simplify each thing individually, each term individually. It's an entire trinomial divided by this binomial. And so the way that you write these out, or you set up long division, is you take the divisor, which is the number on the bottom, and we're going to write that first, x minus 3. You have this weird like bridge bracket kind of a thing. And inside that goes the dividend, or the numerator of your fraction. 2x squared plus x minus 16. So this is the setup for long division. Now there are two very important bullet points I mentioned on the previous slide. We have to make sure that those are good. Number one, are both of those polynomials written in standard form with the biggest exponent first and then going down by 1 every time? They are. Good. Second thing, do we need to put in any zero coefficients? Are there any exponents that like we're missing? Like did I skip over a number from that leading coefficient, from that biggest exponent and down one? Or do we have all the terms already? We're good, right? Because this first one, that's like that x minus 3, technically that's x to the first minus 3. And after the x to the first power, you just have the constant. So we're good. Underneath that division bar, we've got x to the second, followed by x to the first. And then there's no x's, x to the 0, I guess, technically. And so, yeah, those are both in standard form. So we're good. We're all set up for long division. Now here's how it works. You start by comparing the first term out in front to the first term underneath. And you're asking yourself, what do I need to multiply x by to make it a 2x squared? You need another x, and what else do we need? A 2, right? I need to multiply that by a 2x. Now, for those of you who are unsure how to get that or how to figure that out, you just use division. Take the term that's underneath, 2x squared, and divide it by that term that's in front, x. Hey, what do I get when I simplify this? Just 2x, right? 2x. So that's what you're doing, okay? But sometimes it's easier for students just to see, hey, how do I make an x into a 2x squared? Oh, I just multiply by a 2x. So that's going to go up top. 2x. Now notice where I wrote that 2x. I don't think Delta Math does it this way, but I like to do it so that all of the x terms are grouped together vertically, right? Those are all like x to the first will all be aligned vertically. Now, the next part, the next part of this process for long division is you take that 2x up top, and I'm basically going to distribute it. I'm going to multiply it by whatever's in front of that division bar, okay? Just like classic long division. 2x times x is, let me get rid of this. 2x times x is 2x squared. And if you pick the right term up top, those should be the same, right? It's 2x squared underneath another 2x squared. But then I take 2x times a negative 3, and I get negative 6x. All right, so you multiply, and you write that product underneath. And making sure things line up, like see how my x is still lined up with that negative 6x. Does anybody remember with long division, what do we do next at this point? We subtract, exactly. Now to subtract, what I want you to do is put parentheses around this because you're subtracting both of those terms, which is going to flip some negative signs, right? Sometimes the students just write the negative, the subtraction sign, without those parentheses. They only subtract the first term and they totally forget to subtract that second term. So right here, I've got 2x squared minus 2x squared. And if you did this right, those first terms will always cancel. If they don't cancel out, then go back and try to get that term up top again, that 2x. Now here's where we've got to be careful. For that second term, that plus x, we've got x minus a negative 6x, which is actually x plus x, because I'm subtracting a negative. This is like plus a 6x in essence, because I'm distributing that negative sign. So it's x plus 6x, which gives me 7x. That is probably the trickiest part for students. So that's why I suggest always putting it in parentheses to try to remind you to subtract everything underneath. Or if you want, you can just flip the sign of every term when you put it underneath there. And then with long division, once you've done that, then anything else to the right, what happens? Like, what do we do with that negative 16? Drop it down. Yeah, so then negative 16. If there were more terms, you'd bring all them down too, right? You bring down everything else to the right. Now, we just repeat that whole process over again. So now I'm going to look at x, and I want to make it into a 7x. So what do I need to multiply x by to make it a 7x? Just a 7. And again, if you couldn't think of that straight away, just take 7x divided by x, and you see, oh, well, that's a 7. That'll always work for you if you can't figure out what do I need to multiply this by. So I'm going to put a positive 7 right there. Now we take that plus 7, and I'm distributing the 7 out in front. It's going to multiply by everything in front. Okay, well, 7 times x is 7x. And those should match, right? That's why we chose a 7 to make sure they did match. Then 7 times negative 3 is negative 21. And here's where you got to be careful. We're subtracting. But if I just put that minus there, see how it looks like I'm only subtracting that 7x? So we put parentheses, say, oh no, I'm subtracting both of these. All right, 7x minus 7x, this should always cancel out. Now that second term, be careful. It's a negative 16 minus a negative 21, which is like plus 21. So that's going to give us 5. And then we repeat the process. All right, so I've got an x. Can I make an x into a 5 at all? Is that possible? No, you can't. So we're done. But what do I do with that 5? What do we call that part that's left over? Yeah, the remainder. If you have a remainder, all you need to do is write it at the end, plus 5, over whatever your divisor was. What were we dividing by in this case? Yep, x minus 3. Whoa. And so that's our answer. 2x plus 7 plus 5 over x minus 3. Do you remember that long division process now? Is it kind of coming back to you? I know you don't typically use that in recent years, but it's there. Isn't that crazy? Dividing letters from each other? Who knew? Any questions on any of these steps before we practice some more? Here you go, example 2. Whoa. Okay, I'd like all of you to try long division with this one on your own right now. Take several minutes to do this. Set it up right. Look at that first example that I did with you and try to repeat that process. Try to figure it out for yourself. That's the only way you can learn this, is by struggling through it yourself. Don't just sit there blank and say, I'm just going to wait for the teacher to answer it. You're not going to learn anything that way. No one ever does. So don't kid yourself. You've got to actually try this. And if you mess up, that's great. That's where you learn from. We learn from our mistakes. You have to try it and you have to mess it up to learn. The struggle is where the learning comes in. Now, one very important thing to start this off, you may notice both of these are not written in standard form. So make sure when you write that little division, long division bar setup, you put both of these in standard form first. So just double check that your setup looks like mine up on the board, that both of those polynomials are in standard form. And then keep on going with that process. Be careful with the subtraction. Awesome. What's up? No, because you're not dividing them, you're just subtracting. It's like combining like terms when you do that subtraction part. And remember that you're subtracting, so you have to distribute that negative. So it's going to be a negative 4k squared minus 3k squared. That's the tricky part that I said everyone messes up. Yeah. So you look at the first term here and the first term there. That's a k, and that's a k to the third power. You want to make this k into a k to the third. So what else would it need to be multiplied by to become a k to the third power? What could you multiply it by?
Something with an exponent of k.
Well, it already has like one exponent, right? So this is a k. Technically, it's k to the first power, right? And you want to multiply it by something to become k to the third power. So how many more k's do we need, essentially? Yeah, so you just multiply it by k to the second. So that's what goes on top of that division bar.
Okay.
And that's so like right here, we had an x, we wanted it to become a 2x squared. And so first we need a 2 out in front, right? Because this x doesn't have a 2 in front. And then to make an x into an x squared, we needed to multiply it by one more x to make it x to the second. And that's where that 2x came from.
Okay.
So it's the same idea here. To make a k cubed, you need to multiply by k squared, 2 more k's basically. Nice. Yeah. So then you kind of repeat the process. How do you make a k into a negative 7k squared? What else would this need to be multiplied by to become that? It needs another k. And what about the coefficient? Yep. So you're going to put a negative 7k up top. All right. All right, working through it. Yeah. So you take this and you multiply it by that. So that'd be k squared times k would be k to the third. And then take the k squared times 3. What does that equal? Yeah. And then subtract those. All right, I'm going to start walking through this. So from this setup right here, we start by comparing those first terms of the dividend and divisor. And you're basically asking yourself, hey, I'm going to make a k into a k to the third power. So what do I need to multiply it by? And all you need are 2 more k's. So we're going to start by writing a k squared up top. Now, how do I know that the k squared is the right term? Where'd that magically come from? Well, if I distribute k squared times these 2 terms out in front, I start by multiplying k squared times k, and that gives me k to the third. And that's my confirmation right there because it matches what's right above it. I have a k to the third over a k to the third. That's how you know, because you need those to be the same for this process to work. Then k squared times 3 is plus 3k squared. Now we're going to subtract. And here's where you got to be careful. You got to distribute that negative sign. So I'm subtracting the k cubed. They cancel out. But here, this 3k squared is actually like a negative 3k squared because we're subtracting that term. So it's a negative 4k squared minus 3k squared. And this is going to give us a negative 7k squared. All right, so I know some students would have a negative 1 there, but you have to remember that we're subtracting these. And so it's going to flip all the signs in that whole like second line, that second polynomial. Now just drop down everything else to the right. So the minus 30k and the minus 18, they just come along for the ride. And we repeat that process. But now I'm comparing a k to a negative 7k squared. What do I need to multiply k by to make it into negative 7k squared? Well, first off, it needs the coefficient, right? It needs a negative 7 out in front. And then to make a k into a k squared, it just needs to be multiplied by one more k. So up top in the numerator, or above the division bar, we're going to have a negative 7k. we would then distribute just that negative 7k piece. That negative 7k gets distributed to every term out in front. Negative 7k times k is negative 7k squared. That should always be your first check right at this step. Do those two match? Are they the same thing above each other? Yes, they are in this case. That means we've got the right term up top. Negative 7k times 3 is negative 21k. And just remember that we are subtracting these. So if you want, what might help is instead of writing it like this, maybe you just go ahead and flip all the signs. So instead of writing the parentheses, to keep it straight, once you write that bar, flip the signs, because that essentially is subtracting, right? I'm distributing like a negative. It's going to flip all the signs in that second polynomial. So now when I add these up, the 7k squareds cancel out. I now have a negative 30k plus 21k, which equals negative 9k. And I just drop down that negative 18. And we do this process one more time. How do I make a k into a negative 9k? Well, it just needs to be multiplied by negative 9. I then take that term up top that we just figured out, and I distribute it out in front times the k plus 3. Negative 9 times k is negative 9k. Again, check that those two match, and they do. So we've got the right term up top. Negative 9 times 3 is negative 27. You just scroll down for just a little bit. So right here we subtract. And so again, what I think might help everyone keep it straight is just flip the sign of every term on that bottom line. Just flip the signs right now and then just add them up. 9k and a negative 9k cancel out. A negative 18 plus 27 equals a positive 9. But I can't make a k into a 9. So this 9 down there, that would just be our remainder. And so the way that we write remainders, it's positive, so I put plus 9 over whatever that divisor was, over k plus 3. So this right here is your quotient. Anyone else get that? Or part of that? Did you get at least a few terms correct? Okay. Awesome, awesome, awesome. I know what you're thinking. It's a long process. You're right. But I mean, it is in the name, isn't it? It's called long division. Can't expect it to be short. That'd be crazy. But each step individually is pretty simple. We're multiplying and we're adding. Those steps are pretty simple in themselves. There's just a lot of multiplying and a lot of adding, which makes it a longer problem, but it is not a difficult problem. It's not a difficult process. But just like multiplying matrices, for example, you have to practice this enough times until you get that pattern down, until it's so familiar to you. You know, run through 10 of these at home and you'll be great at it. All right, try another one. Oh, I know, that's the tricky part, right? By the way, this one's a little tricky. Yeah, I added something new to this. What? You done yet? Okay, 1 sec. What's the answer? Oh, got it. Like 3 of them or a couple hundred? What do you have to be careful of with that first polynomial, everybody? Liam, yes, exactly. We're missing a term, aren't we? Did you know that, Michael?
Of course I do.
You didn't. He was going to mess it up, do the whole process. So if I look at the exponents, See how there's x to the third, x to the second? What are we missing? X to the first. So what you need to do is like right here, you need to squeeze in like a plus 0x. Okay, so there's 0x to the first. Good catch. So there are technically 4 terms there. So you need that 0 because it's going to come into play when you do your subtraction and everything like that. You need that placeholder. And if you forget that 0, I'm going to call it pulling a bunion. Haha. So set up the division bar, but make sure underneath that division bracket, you've got 4 terms. Got to keep that 0 term in there. Nice. Yeah, what's up? So put that right here, plus 0x. And then afterwards, you'll put the plus 9. Yep, that's exactly right. Now just do the regular long division like we've been doing, okay? I love the color coding. It's awesome. I know, the first time. It is, it is. If you do this right, there should be no remainder. Spoiler alert. That's a good feeling, right? It's tough keeping track of everything, right? So here's what the setup should be for the division. Again, there are 4 terms in the dividend. To start the process, we compare the first terms in each polynomial. How do I make a 2x into a 6x cubed? Well, to make a 2 into a 6, it needs to be multiplied by 3. And to make an x into an x to the third power, or x cubed, it needs to be multiplied by an x squared. So starting off, I'm going to have a 3x squared. Distribute that to both terms out in front. 3x squared times 2x is 6x cubed. Do a quick check here. Do those match up? They do. So keep going. 3x squared times 3 is 9, positive 9x squared. Then remember right here we're subtracting. So I think the easiest thing to do, maybe just put those negative signs, just switch the signs in front of every term to help remind you that we're subtracting these from each other. 6x cubed minus 6x cubed cancels out. Then I've got 5x squared minus 9x squared. That's going to give us a negative 4x squared. Then just drop down the rest of the polynomial, the rest of the dividend, and we repeat the process. To make a 2x into a negative 4x squared, we need to multiply it by a negative 2x. Distribute that out to the front, to each term of the divisor, and we get negative 4x squared and a negative 6x. Now remember, we're subtracting those two terms, so go ahead and change their signs to indicate subtraction. Those first terms cancel out, and I've got 0x plus 6x, which is nice and easy. That's plus 6x. And drop down the rest of the polynomial, plus 9. And we repeat that process one more time. I want to make a 2x into a 6x, which just needs to be multiplied by 3. Then take that positive 3 and distribute it out in front, each term of the divisor. 3 times 2x is 6x. 3 times 3 is 9. And remember that we're subtracting these, so you flip all the signs in those terms. And hey, what happens here? Right? That cancels out. That's a 0. That cancels out. There's no remainder. You don't need to write the plus 0 over 2x plus 3. It just works out nicely. And our answer is right there. Anyone have that? Just out of curiosity? Oh, that's fantastic. Awesome job, class. Way to go. Oh, did you? After Liam helped you, you mean? After he gave you the big hint? Can you imagine doing all this and forgetting the 0? Oof, that'd mess you up. All right. I know, this is long. We don't have to go through this one. I just want to show you, again, be careful. It's just more and more terms. You're going to have plenty of practice like this tonight on your Delta Math. But what do you have to be careful of with the divisor in this case, everybody? Yeah, that 0 term. So you'd make this 3x squared plus 0x minus 4. So you could be missing terms in either the dividend or divisor, but then the process is the same. But again, I'm not going to walk through this process right now. You seem to be getting it. All right, that last example went really well for most of you. So this is just going to take more time. But I think you pretty much have it for now. If you really want to know the answer to this later, feel free to meet up with me after school, send me an email and be like, Mr. Wojcik, I think I got it. And I'll double check that for you if you really want to. But for now, it seems like we're pretty good. Oh, and what else are we missing in the yeah. Yep, so we need the constant plus 0. Yeah, right. You can't even count to 0. Sorry, it's the haircut. Hair got cut, and now I cut up on you. Wow. No, Liam, it's called washing his hair. Oh my gosh. I know. That's ridiculous. All right. So this is an easier process. There's a special type of division, but we can only do it with certain conditions, okay? Look at this divisor right here. if you notice that it's a division problem and it's just an x to the first power, you can use this new super secret, awesome shortcut method that doesn't take nearly as much space, and it is so awesome. But you can only do it when it's just an x to the first power. It's the only way that this works, okay? So you're looking right here at the divisor. It's got to be like an x by itself. And if you recognize that, then instead of using long division, we're going to use this really cool shortcut method called synthetic division. This is the second process I'm going to show you today. That's kind of weird because does anyone know what the word synthetic means? Have you heard that before? Something that's synthetic? What? You heard it in a superhero movie.
Synthetic clothes.
Synthetic clothes. Something that's synthetic is fake or manufactured, created. So this is actually called fake division, everybody. You know why? Because we don't actually divide at all with this process. We just multiply and add, but there's no division. So this is called synthetic division. We actually don't even use the variables. It's crazy. But you can only do it in certain conditions, right? If you're dividing by a linear binomial, meaning it's just an x to the first power, x without an exponent. If you recognize that, then we can do this process called synthetic division, which is super quick and easy. It's a fabulous little shortcut method. You will be using this method a ton next year in pre-calculus for sure. And it is a gorgeous, poetic piece of mathematics. Okay, who's excited? Be honest, did I, get you pumped for this yet? Did I build it up enough? Yes, sir. Great question. Yeah, like if we had something like 2x plus 1, right? That's still a degree of 1. You can do it this way. We're typically not going to, but essentially we would want to make it so that it's just x without the coefficient. So like to get rid of this 2 in front of the x, what would we have to do? Divide by 2. I'd have to do that to both terms, though. And so then that would give us like x plus 1/2. So you'd have to change it to that, which you can do if it's x to the first power. And then you'd be using this 1/2. So you got a fraction, which could be a little messy. But yes, it will still work, even if you have a coefficient. You would just divide the constant by whatever that coefficient is, essentially, to make it just x to the first power without that number in front. Awesome, awesome catch, Ben. Okay, so let's look at this process. That's that same polynomial from that example. You're going to need some more room, though, than one line. I know you have to flip your notebook over. It's crazy. She's so sad. So, synthetic division. I've got x to the fourth minus 2x cubed plus x minus 1, or dividing it by x plus 1. So first off, do the check. Can we use synthetic division for this problem? Yes, we can. That's an x to the first power. We're good to go in the divisor. Are we missing any terms in the dividend? Michael. Starting with x to the fourth. Now count down with your fingers.
We're missing 2.
Oh, look at that. Okay, so right here, we got to put a 0x squared. Yep, same rule. You need to have those placeholders in there. We even called you out on it, and you still didn't catch it right away. Eventually. Liam won't always be here to hold your hand, right? All right, so here's how the synthetic division works. First, there's the setup. Step number 1. Draw a half box in the upper left corner. Super important. Yes. Jeez. Of your space where you're going to be writing stuff. This is the top left of where the line's going to go. In that half box, this is very important. look at your divisor. Specifically, look at whatever's being added or subtracted from the x. You're going to take that number and you're going to flip its sign and you're going to put it in that half box. Essentially, the number in the half box is whatever value you could plug in for x to make this a 0, right? So like what number plus 1 equals 0? Would that be a negative 1? That's why we're flipping the sign, okay? That's why I'm putting a negative 1 there. We're looking for something called the zeros of this function, essentially. Now, here's the easy breezy part. To the right of the half box, you're just going to write all the coefficients of the dividend. So basically, like, how many x to the fourths do we have? Like, what's the number in front of the x to the fourth? There'd be an invisible 1. Okay, how many x to the thirds do we have? Negative 2. Yep, the negative sign is important. So negative 2x to the thirds. Hey, how many x squareds do we have? 0. So we got to put that 0 there. What's the coefficient of the x to the first? It's just a positive 1. Then last we have the constant, which is a negative 1. Everyone okay so far? Where we got all those numbers from? Just in front of all the variables. Now, very important step right here. Are you ready? Skip a space and then draw a horizontal line. Make sure you skip a space. We're going to be writing stuff on that line. Skip a space. Yeah, that's good. This is our setup for synthetic division. Now is where it gets really easy breezy. Does everybody have this setup? Let me make this look like the fancy one. Okay, everyone have it set up? All right, here's how it works. You start with the first term. So you don't use the number in the half box. That's like a special dude. That's why it's in the half box. It's special up there. You go to all those coefficients. Start with the first coefficient, and we always just drop down the very first coefficient. Whatever that number is, just drop it below the line. And now here's how this process is going to work. You take the number below the line, which is a 1, and you multiply it by the number in the half box. So what's 1 times negative 1? A negative 1. Whatever you get is going to go above the line, but 1 spot over. So 1 times negative 1 was negative 1. That's why I wrote a negative 1 there in red underneath the negative 2. Now, take that second column of numbers, the negative 2 and the negative 1, and just add them up. What do we get? Negative 3. Repeat the process. You take this number that's below the line, which is a negative 3, and we multiply it by that special number in the half box. What's negative 3 times negative 1? Positive 3, or just a 3. So we're going to write a 3 above the line, but 1 spot over. Now look at that third column. Add those numbers together. What's 0 plus 3? It's just a 3, positive. Repeat the process. I take this 3 times that special number in the half box. 3 times negative 1 is negative 3. We write that above the line, but the next spot over. Add those up. What's 1 minus 3? What? Oh my gosh. Oh my gosh. I'm calling your parents after class. Negative 2 times negative 1 is positive 2. Add those up. Positive 1. The last number, once we're done, put a box around it. Because that number at the very, very end is our remainder. And what about all these other numbers here? What do you call them? What's the name for these? coefficients. These become the coefficients for our polynomial, but there's one thing we need to change. The degree was originally x to the 4th power, right? But we divided every one of these by an x to the 1st. So what's going to happen to the exponent for every term? They're going to drop by 1. So this first term, this 1, instead of writing x to the 4th, this is actually 1x to the 3rd. You drop it by 1 exponent. Then just count down the line. Check it out. This is x squared plus x minus 2. Minus 2 is our constant. You just put the x's in. Boom. So plus the remainder. What do we always put the remainders over? Not the special number, but what did we originally divide by? Yeah, we originally divided by x plus 1, so that would go underneath that remainder over x plus 1. Does that take up less space than long division? Is that nuts? How that works? It's crazy. So just to clean this up a little bit, this would be x to the 3rd minus 3x squared plus 3x minus 2 plus 1 over x plus 1. That's magic. That's synthetic division. Crazy. Oh, man. Do you like this better than long division, do you think? We'll practice it. We'll try it. We'll do a couple. Any questions on any of these steps at this point? Okay. Here you go. Try this one on your own. And while you're working through it, I'm going to pass back your test for you to take a look at, okay? So if you can use synthetic division, you always should. So remember, there's that one condition you have to check for. So can we use synthetic division for this problem? Yep, because that's a y to the 1st power that we're dividing by. So yes, you can. Set up the half box, make sure your dividend is in standard form, and just write all of those coefficients out. You're welcome. Maximize storage volume. The 10 and 20 are dollars. So let me show you what the setup would be. First, I need to make sure this numerator is in standard form. So I have my y to the 3rds plus, 3y squared minus 7y minus 21. There we go, 3, 2, 1, 0 with the exponents. I start by flipping the number of the divisor to go in the half box. And then to the right, I'm just going to write down all those coefficients of 1, 3, -7, -21. Skip a space and put a line. Just see if you can go from there as you keep looking over your tests. All right, so from this setup, here's our process. We start by dropping that very first coefficient down, so that's a 1. Then you multiply that number by whatever's in the half box, so a -3. 1 times -3 is a -3. Add those up. A 3 plus a -3 is 0. Multiply by the number in the half box. We get a 0. Add them up, get a -7. -7 times a -3 is +21. When I add these up, we get 0. What does that 0 mean? Yeah, no remainder in this case. So remember, always box up that last term just to kind of reminder, oh, I don't have anything here. It's just the remainder. And then from here, we started with an x to the 3rd power, right? The degree was 3 originally. So now the degree is going to be a 2. You drop it down 1. So this is x squareds. This is how many x's. That's the constant, and there's no remainder. And so we would just clean this up a little bit by writing simply x squared minus 7. Yes, it would be y. That's right. Y squared minus 7. Good catch, sir. You've redeemed yourself. Anyone else have y squared minus 7? Yep. Yes. It's awesome. All right, we're getting pretty good at this. Let's do another just to really hone it in. Make sure we've got this down pat. Michael, are we missing anything? What are we missing? Yep. All right. Make sure you put 2 of those 0 placeholders in there for this one. How many of you think Michael's going to forget to put in the zeros on the test? Michael, some people actually raised their hands at that question. Any other questions? Awesome. Oh, who put that wall there? The magical half box. Yeah, you add up those columns. -4 goes in the half box. And then my line of coefficients are 8, 32. Here's the important part. 0, 0, 5, 20. Skip a space, draw a line. So that's your setup. Make sure you've got that set up. Isn't that crazy? And you're going to get a somewhat unexpected answer. Right? A boatload of zeros. Yeah, it looks like everyone's getting it. Awesome. Yep. So then that times this. Perfect. And just repeat that process. Nice. So we drop down that first term, that 8, multiply it by the half box, add them up, multiply, add, multiply, add, multiply, add. 5 times -4 is -20. Add that up, we get a 0. Right away, put a box around that last number to remind you, hey, that's the remainder. Do you like it when we get a remainder of 0? Yeah, it makes it look a lot nicer, cleaner for that final answer. But now what do you do with all these zeros? So the original degree was a 5, but we divided by an x to the first, so you drop it down by 1 degree, 1 exponent less. So instead of v to the 5th, this becomes 8v to the 4th. Then you have v to the 3rd, v to the 2nd, v, and then that last number is just what we call the constant, right? There's no variable next to it. It's always going to be a 5. And anything with a 0, we don't need to write that in our final answer, right? 0 times anything is 0. It just cancels out. You don't even put it in your final answer. So we've got 8v to the 4th plus 5. Anyone else get that? Yeah! That's what I'm talking about. You got this. Look at this. And it's early in the morning still. And you're blowing my mind. This is fantastic. No, I don't support gang signs. Hey, everyone, that's our lesson. You did it. Any last minute questions? Okay, 1, 2. Oh, you only do 1 sheet of paper?
Yeah, and I had to go over.
You poor child.
I decided to do a long lesson today.
What do you mean I decided to do a long lesson today? It just happened to be a long lesson. Aliana, it's called long division. I mean,
I like being organized. And look at this. I had to go over it. And now this is blank.
It's gonna mess everything up.
Yeah.
Your life is over as far as we know it.
Because I have
I apologize. Hey everyone, I want to show you the delta math real quick just to help you work through these. You have 4 challenges, 2 sets of long division, 1 easy, 1 advanced, 2 sets of synthetic division, 1 basic and 1 more advanced. And when you're writing these out, you're going to have to work it out by hand. But as a nice little shortcut, when you're typing things into Delta Math and you need to do an exponent, because that happens a lot. So I don't know what this really is, but let's say it's like 2x squared. To do x squared, a nice shortcut is hold shift and press the number 6 on your keyboard. And there's a little like, looks like a caret, like an upward arrow thing. And that makes the cursor jump. See how it's in like the exponent spot right now? And then if you just hit tab, the cursor drops back down to the regular level to keep on writing. So just to make it a little bit easier when you're typing in your Delta Math answers, just use that Shift 6 to do an exponent. Then also submit your answer. You can just press enter, enter, instead of having to click with your mouse pad, so just enter, enter to submit it. That should help speed things along. Bye, everybody. Oh, I got it wrong. Well, that's because, if you look at the first terms, 4x cubed and a 2x, so I did actually divide that. But thank you for the vote of confidence. Bye, everybody. You did great.